Did you know that high divers contain the same amount of energy whether they're standing on the edge of the platform, falling quickly, or just about to hit the water? Today's lesson is on work and energy. So, recalling from Science 10, work is the energy transferred to an object when a force is applied that causes that object to move. So, in order for work to be done, there are three conditions that must be satisfied. The first is a force must be applied. A push or pull must be applied to that object. And so, therefore, an object that's coasting is not having work done to it. Condition two is that there must be movement. If the force is not large enough to change the object's motion, there's no work being done. So, no matter how hard I push on a wall or rock, if I can't move that wall or rock, no work is being done. And condition three is that the direction of the force and the movement must be in the same direction. So the movement has to be as a result of the force, so therefore they have to be in the same direction. So if a rock is rolling downhill and I'm pushing it uphill, but it's still rolling downhill, even though it's moving, no work is being done. Energy is the ability to do work. When a certain amount of work is done on an object, that object can gain that much energy. So if I lifted a rock up from the ground to the table, I added energy to that rock. And there are different types of energy. There's kinetic energy, the energy of movement, thermal energy or heat energy, solar or light energy, electrical energy in the movement of electrons, potential energy, which is stored in readiness. It could be chemical stored in bonds, gravitational stored in an object that can fall, and elastic, as in a stretched elastic or a compressed spring. Potential energy can also be gravitational potential energy. So if an object is lifted up, the energy acquired is gravitational potential energy. This is due to the position of the object above the Earth's surface, like that rock that I put on the table. Gravitational potential energy is energy stored in an object that has the potential to fall. So to calculate this, we take the mass of the object in kilograms, multiply it by acceleration due to gravity, and height in meters. So this is gravitational potential energy is proportionally affected by mass and by height. So the higher the height, the more potential energy, the larger the mass, the more potential energy. So kinetic energy is the energy that occurs when an object is moved. The energy acquired due to the work done is kinetic energy. The formula is EK equals 1/2 mv squared. Kinetic energy is measured in joules with mass in kilograms and velocity in meters per second. So this is again going to be affected proportionally by mass, but exponentially by the speed at what an object is traveling. So in a closed system where no work or no energy is added or subtracted, the law of the conservation of energy applies. This means that energy changes from one form to another, but the total amount of energy in the system remains constant. So in the case of an object that's rising straight up into the air or falling, there is a constant transfer of kinetic energy to potential energy and potential to kinetic energy. When the object is at its maximum height, it has its maximum potential energy, and its kinetic energy is virtually zero because it's not moving up or down. When the object is just about to hit the ground or just about to leave the ground, it has its maximum kinetic energy because it is at its lowest point compared to the Earth. Anywhere in the middle of the journey, there's a combination of potential and kinetic energy, depending on where the object is in relation to the ground. And the sum of the energies at any point of the falling objects will remain equal. So the potential energy of the object, just as it reaches its peak and stops moving, is the same as the kinetic energy, the just about it before that object hits the ground or before it leaves the ground. So another example, at the top of this diving board, the diver has maximum gravitational potential energy, but since he's not falling, no kinetic energy. As the diver falls, his height decreases, so his potential energy also decreases. However, his kinetic energy is going to be increasing because his velocity is increasing. And in this whole scenario, the diver's mass is going to be staying the same. So because that gravity causes the diver to accelerate, his kinetic energy increases. The moment the diver strikes the water surface, he's at ground level, so there's no more potential energy. However, he has reached his maximum velocity, so he has his maximum potential energy. Because energy is conserved in a question involving a rising or falling object, the two formulas, potential energy and kinetic energy, can be set equal to each other. So mass times gravity times height is equal to 1/2 mv squared. And mass is going to be the same because it's the same object on both sides of the equation, so it will cancel each other out. This gives us the equation gravity times height equals 1/2 velocity squared. So if the diving platform is 10 meters high, what will be the diver's velocity when he reaches the water? So we have a height of 10 meters. Gravity is going to be positive because the height is going to be decreasing, and we're going to have a negative acceleration as it's falling, so they'll both cancel each other out. And now we're going to look for velocity. So we can cross out mass because the mass of the diver doesn't change during the equation, and rearrange it by multiplying both sides by 2 to get 2 times gravity times height equals v squared. Now we have to take the square root of both sides to get velocity. So the square root of gravity times height, 2 times gravity times height, is equal to the velocity. Putting in our known information, the square root of 2 times 9.81 meters per second squared times 10 meters gives us a final velocity of 14 meters per second. Another example of a conversion between kinetic and potential energy is a pendulum. So at position A, the pendulum is not moving, but it is at its maximum height, giving it the maximum potential energy and its minimum kinetic energy. At position B, the pendulum is moving at maximum speed, but is closest to the ground. So it's going to have its minimum potential energy and its maximum kinetic energy. At position C, the pendulum is at the same position as position A. So again, it will have its maximum potential energy and its minimum kinetic energy. Thanks for joining our lesson today. I hope you enjoyed it. Bye.